A pipeline that waits. No annotations, no magic, just functions. We'll build a lazy engine like Streams, where map and filter don't run until you ask for results. You'll see inside every Java stream you've ever used. We start with package seek. This tells Java the class lives in the seek folder. Imports bring in collections and functional interfaces. LazySeq is a generic container that will hold any element type. Unlike the previous DI or ORM examples, there are no annotations here, everything is pure functional composition. Two fields define the entire pipeline. Source supplier is a lazy factory that creates a fresh iterator over the data, or infinite stream. Stage functions is a list of transformer functions, each one wraps an existing iterator and produces a new one. The constructor is private, users create pipelines only through static factories, preserving immutability. Of wraps any existing collection into a LazySeq. Iterate creates an infinite, lazy sequence from a seed and a function, the iterator never ends. Neither method triggers computation, they just prepare a supplier that will later supply elements. Map doesn't transform elements immediately. Instead, it adds a stage, a decorator iterator that, when next is called on it, pulls a value from the upstream iterator and applies the mapper. The new LazySeq is a completely independent pipeline, still unevaluated. Filter also adds a stage. Its iterator uses advance to skip non-matching elements, storing the next matching one in next item. This look ahead is exactly how the Java Streams filter works. Again, no actual filtering occurs until iteration begins. Limit adds a counter that decrements on every next. Once remaining hits 0, has next, returns false, effectively stopping the pipeline. Combined with iterate, it makes infinite streams safely finite, a core feature of functional pipelines. Build final iterator chains all stage functions around the source iterator, producing the final pull-based stream. Terminal methods call it and then drive iteration. Only now does data flow, every map, filter, and limit runs on demand, element by element. Build final iterator chains all stage functions around the source iterator, producing the final pull-based stream. Terminal methods call it and then drive iteration. Only now does data flow, every map, filter, and limit runs on demand, element by element. The print lines inside filter and map prove nothing runs before toList. When the terminal triggers, you see each element pass through filter then map, one by one, a true pull-based pipeline. The output order reveals the lazy evaluation pattern. You've built the heart of Java Streams. Lazy pipelines aren't magic, they're iterators wrapped in functions. Understanding this makes debugging, performance tuning, and reactive programming second nature.